And here's a sample conservation of energy problem. It says a bowling ball is dropped from a height of 20 meters. What is its velocity just before it hits the ground? Okay, so first couple things we should do, like usual, is write down some of the given information, also make a diagram. So initially, here's some ball. It's 20 meters off the ground. And then afterwards, it's just about to hit the ground, and it's got some downward velocity. We don't know what that velocity is, in fact, so that's what we're going to look for. We know that the initial height, h, equals 20 meters. It says it's dropped, so the initial velocity is 0. That tells us in terms of the energy, that the initial kinetic energy is 0 joules, of course, and that initially we have some gravitational potential energy. And then later on, right, that at the end, the final height is 0 meters, and the final velocity is what we're looking for. Okay, so how are we going to do this? Well, initially, like we said, there is gravitational potential energy. There is UG here, and then later on there is K, and that's it. There are no other energies involved. Otherwise, this would be a little bit more complicated. So I can write out this equation that the initial gravitational potential energy is equal to the final kinetic energy. Notice no mass is given. Okay, so I can substitute in now. UGI is mgh, the initial height, equals 1/2 mv squared. All right, so that's the equation that I can use now to solve for the final velocity. When I solve this, by the way, notice the m's just cancel out, and so I'm left with gh equals 1/2 v squared. I'll move over here. So gh equals 1/2 v squared. I'll multiply both sides by 2 in order to get rid of the 1/2. Now I have 2gh equals v squared. Now how do I get rid of a squared? I take a square root. So now I have the square root of 2gh equals v. Now keep in mind, g is the acceleration due to gravity, which is 10. So I plug in the numbers. 2 times 10 times 20 is v. And this turns out to be 20 meters per second. That is the final velocity just before it hits the ground. And again, notice you don't need the mass there. Okay. Now I have this other question because it's solved the same way. We imagine a roller coaster cart. So roller coaster cart begins at rest at a height of 20 meters. So imagine some roller coaster type scenario. Right. And the roller coaster cart begins up here. Oops. And then it ends down here. Initially, it has a height of 20 meters. The initial velocity is 0. And then afterwards, it has some velocity this way. And of course, the question is, what is that final velocity? Well, it turns out to be exactly the same. I can take all of the math that I did here, and it's exactly the same for this. Because it has all the same initial conditions. The initial velocity is 0. It has gravitational potential energy. At the end, it has kinetic energy and no gravitational potential energy. So it's the same equation. The initial gravitational potential energy equals the final kinetic energy. And I solve it the same way. And again, I don't need the mass. Everything works out to be the same.